Okay, hello everyone. We are on the second part of our video. Okay, as I've mentioned in the previous video, we have to note that the sum of two matrices is only defined when these two matrices have the same number of rows and the same number of columns. So that is when A and B are of the same size. So some would ask, paano po kung magkaiba yung size? So definitely, we cannot get the sum, or we will simply say that the sum is undefined. Okay? Then, while I need to navigate this. Okay, next. Next definition, scalar multiplication. If matrix A is an M by N matrix, and R is a real number, then the scalar multiple of A by R, denoted by RA, is the M by N matrix C, wherein Cij is equal to R times Aij, wherein I is from 1 to M and J is from 1 to N. That is, matrix C is obtained by multiplying each entry of matrix A by R. So, when we say scalar multiplication, we multiply a given matrix by a certain constant or a certain real number. And to multiply a constant or real number by any matrix, all we need to do is to multiply that real number to each of the entries of that matrix being considered. Okay, say for example, if we have negative 2 times this 2 by 3 matrix containing the entries 4, negative 2, negative 3, 7, negative 3, 2, and then to get the product between these two, this real number, this constant, and this matrix, all we need to do is to multiply negative 2 by each of the entries in the given matrix. That is negative 2 times 4. We have negative 2 times negative 2. Then negative 2 times negative 3. Then negative 2 times 7. Then here, second row, second column, negative 2 times negative 3. This one is 2. And then we have negative 2 times 2. So, the matrix that we will obtain is contains negative 8, then positive 4, positive 6, negative 14, negative 2, negative 3, that's positive 6, and negative 2 times 2 is positive 4. So it is as if we're just distributing that constant factor. But that is the scalar multiple of this matrix. The scalar multiple of this matrix. Okay, so let's have another one. Probably, I still need have space here. If, for example, we have 5 times 3 to negative 1, 6 plus 2 times negative 3, 4, 1, negative 5. Okay, so let us combine matrix addition and scalar multiplication. So let's see what we will get here. We have, first, we multiply 5 by each of the entries on the first matrix. So we have 5 times 3, then 5 times 2, then 5 times negative 1, and then 5 times 6. And then plus, we multiply 2 by each of the entries here. So we have 2 times negative 3, then 2 times 4, 2 times 1, and 2 times negative 5. Okay, so let's get the scalar products. Now, we have 5 times 3 is 15. Then 5 times 2, we have 10. 5 times negative 1 is negative 5. And 5 times 6 is 30. So we have a 2 by 2 matrix, definitely, because the given matrices are both 2 by 2. And then plus, now let's get the entries in the second matrix. 2 times negative 3 is negative 6. And then 2 times 4 is 8. And then 2 times 1 is 2. And 2 times negative 5 is negative 10. So we are done with getting the product. The next thing that we will do is to add these two matrices. So since these two matrices are both 2 by 2, since this is 2 by 2, then this is also a 2 by 2 matrix. So they are of the same size, hence we can get the sum. At paano nga natin ina-add? Just add the corresponding entries. So we have 15 plus negative 6. 15 plus negative 6. Okay, let me create a space here. Okay, that's better. 15 plus negative 6 is positive. Oh, what's that? It's 9. Okay, 9. And then we have 10 plus 8 is 18. And then negative 5 plus 2. Negative 5 plus 2, that's negative 3. And then, the third one. 30 plus negative 10 is positive 20. So this is now, okay, let me reduce that. This is now 5, okay, a little up. 5 times this matrix plus 2 times this matrix will give us this 2 by 2 matrix. So, pwede natin pagsama-samahin yung matrix operations. Nauna kanina yung matrix addition, and then we have this concept about scalar multiplication, and now we can perform operation, okay, a more complicated operation. But this one is easy actually. It's not a complicated one, but this is more complex than the previous examples. Okay. So take note of this. If A and B are m by n matrices, we write A plus negative 1 times B as A minus B and call this the difference between A and B. So this is how we do subtraction of matrices. It is as if we're getting the difference between A and B, it is as if we are adding A by n, we are adding A in the negative of B. Okay, that's A minus B. Okay, for example, if we have matrix A to have this entries, this one I want to have negative 1, 5, 3, 2, negative 4, 6. And then we have matrix B to have 4, 7, negative 2, 1, 3, 8. Okay, say for example, we have this two matrices, then A minus B is equal to A plus negative 1 of B. So this is equal to A. This is equal to the entries of A are negative 1, 5, 3, 2, negative 4, 6, plus we take the negative of B. So the scalar product, all we need to do is to multiply each entry of B by -1. So that will give us -4, -7, positive, negative of -2, that's +2, -1, -3, and -8. And since we are now performing addition of matrices, both these two matrices have the same size, 3 by 2. So let's add the corresponding entries. -1 plus -4. Oops. Where's that? Okay, -1 plus -4, that's -5. And then we have 5 plus -7, that's -2. And then 3 plus 2, that's 5. And then 2 plus -1 is 1. And then -4 plus -3 is -7. And lastly, 6 plus -8 is -2. So A minus B is equal to a 3 by 2 matrix whose entries are -5, -2, 5, 1, and 7. -7, negative. So this will give us A minus. So like the previous example, we can extend this. Okay, let's perform another operation. What if we'll have 2A minus 3B equals. Okay. Or let me place the equal sign. So 2A minus 3. So let's perform 2A minus 3. So that's 2 times matrix A, -1, 5, 3, 2, -4, 6. Okay? Plus -3 times matrix B, 4, 7, -2, 1, 3, 8. Okay? So this is equal to, let's perform, oh, where is that? Let's perform the scalar multiplication first. So that will give us, okay, multiply each entry by 2. We have -2, 10, 6, 4, -8, 12. Close this. Plus, the second matrix will be multiplied by -3. So that will give us -12, -21, +6, -3, -9, and -24. And then afterwards, we add these two matrices. Pareho namang 3 by 2, so we can get the sum. We have -2 plus -12 is -10. Then 10 plus -21 is -11. 6 plus 6 is 12. 4 plus -3 is 1. -8 plus -9 is -17. And 12 plus -24 is -12. So this will give us 2A minus 3. Okay. So we have this example. Okay, nauna na yung example ko bago dito. I think I have that. Oh, I was able to give the example, and we will end the second part of the discussion, 2/2 part of the discussion about the introductory concepts of matrices, So again, to wrap up the discussion, a matrix is an array of an n by n numbers. It could be real number or complex number, but in our case, we will focus much on real numbers. So it's an array of mn numbers, okay, arranged in m rows and n columns. Okay, so it's just an arrangement, and we were able to identify the entries on a i ith ijth column of a given matrix. And then afterwards, we perform matrix addition. We can say that two matrices are equal if their corresponding entries are equal. Okay? So that is, they have basically nakapasok na doon yung idea that they are of the same size. They have the same number of rows and the same number of columns, and their corresponding entries are equal. So those are equal matrices. Then we were also able to get the sum of two matrices, and we will stick to the fact that it is only defined when when the matrices are of the same size, or if they have the same number of rows and the same number of columns. And to perform addition, all we need to do is to add their corresponding. Now, when it comes to scalar multiplication, so when we say scalar multiplication, we multiply a given matrix by a constant or a real number. And to perform the operation, all we need to do is to multiply that constant to each of the entries of the given matrix. So I will pause the discussion here because I will give some exercises for you to practice about that. Thank you for watching. I hope that you learned something from our discussion. Stop sharing.